All right, let's go to work. So this is an old resin pen, repair pen, where you put the resin in to whatever you're repairing, and then you cure it with a UV light. Curing, in case you don't know, which would be weird on this channel, but you could be a first timer. Basically means drying. It's setting. It's being completed. This is actually done a lot in dentistry. I actually tell my dentist all the time you should be putting UV protected lenses in the eye guards for the staff, but we're not going to get into that. So originally, I actually ended up needing this for a couple of other repairs now. But I remembered that I had this, and I remembered that I had this little module, and this module comes out. So for now, we can just wrap this up. That was kept in a toolbox, and the toolbox is out in the garage. I haven't seen this thing in years, and I went out and it was -8, and the resin is just like coming out of the thing. So I'm like, whatever. But obviously also the batteries are dead. So we're just going to go ahead and open this up. I love these precision, like they almost always work. But I love them because basically what you do is you push it against your palm into the screw so you can get a really good bite into the screw. And then as you're pushing down, you twirl it because this spins. Love it. Now we're going to keep that screw there for the time being, and we're going to open this up. And I think it's important that we open it up and we turn to this side, because then we can make sure to grab the power switch right there. Now, here's the fun part. All that power switch does really is hold this leg directly onto the plus side of this battery. That's it. And then these batteries are just put together in series, which really means that the positive back is connected to the negative front, so that the positive of both is back here and the negative both is now up here. You're just adding the two batteries together. And now that you see that, by the way, look at anything else that takes batteries, and you'll notice, like, oh, all those AA batteries in this radio, those are now I understand that they're in series. Oh, okay, great. So that means that 6 batteries, because they're all 1.5 volts, equals 9 volts, and that's why my 9-volt thing could have worked with a 9-volt battery. We'll get into that, but that 9-volt battery also has very low amp hours, or hours that it'll work at a certain rate. Now, first things first. Here's the UV bulb. The longer lead is always positive, shorter lead is always negative. Sometimes the positive will be straight down and the negative will be kicked out a little bit and then bent down. In this case, obviously, the reason why they're both kicked is to wrap around the battery. Now, I really want you to notice, because any hobbyist... Ooh, shoot. I feel like I just gave myself a jolt, but I don't know how. I would have. Any electronics hobbyist would knows that usually, especially with an LED, there's a resistor. The reason why is because a an LED will easily break if there is too much current or wattage. Wattage is your volts times your current. Now you could have very low amps with a regular voltage, because these two together would usually be 3.1 volts. Yeah. I keep thinking 3.7, but that's a lithium ion battery voltage that's common. So these are usually about 3.1 volts, 3.2. Put them together, they're now about 6.2 to 6.4. Oh, something got done installing on the Xbox there. And this LED in our little diagram up here takes, and I looked this up to make sure, and all of the evidence kind of goes with this. You know what? I'm going to do a very common thing, and this is something that my father would always tell me as well, is you take the screw and you put it back into the hole that it's supposed to be for. And actually, you know what? I'm going to put this all back together without the batteries, because I do have new batteries coming, and they're rechargeable, which really makes me happy. Rechargeable coin cell batteries are insane, because unlike the AA and AAA versions, they have the same voltage as your non-rechargeable batteries. Anyway, going back up to here. So here's our diagram. Now, from the information that I could find, and this is a little bit harder because, as you can see here, this is a CR 2016, which means I know what it is. This has no label. I have no idea what this is. What I can't look up what the actual thing is, but I did look up a 6-volt curing UV LED, and yes, different LEDs have different voltages. So this is 6 volts, obviously. That's what the batteries are telling us. There's no resistor. So whatever these batteries output has to be within the tolerance of this LED. Because again, anything more, I think it's like 1.37 amps, but I'm probably wrong on that. But like that's usually the amount that, especially a small LED like this, a through-hole LED no less, which it's called a through-hole LED because it's mounted into a circuit board, and the circuit boards commonly have, especially if you look back at the 50s, have holes in them. And you would push this through and solder it on the other side, or solder it up there and clip off the other side. Ideally, it would be through. And that's why it's called through hole, because you can put it through the holes of a circuit board. So, looking at it, it has to be within 20 milliamps current for this, so it doesn't break. Looking at these batteries, looking at the operating, because some batteries have an operating current. That's what these batteries have, is a Circa, which that's what this symbol is up here, Circa, or around or nearly 20 milliamps. And that's why there's no need for a resistor, because these will only output roughly, that's what this symbol is, roughly 20 milliamps. And that's why we know that we have the correct information for this LED. Roughly. We roughly have the correct information. So, going on that, making sure that I have 20 milliamps, which is 0.2 of an amp. So, oh my gosh, I can't even remember. This is like beaten into me in electronics school. It's like mentioned so many times. It's like one past the decimal point is like deca, and then I want to say it's like micro or something, but it's I want to say it's milli is at the thousandths place, and then I think like pico or micro, one of these two is switched around, I think. But we're on the milliamps. So 1 milliamp would be 3 decimal places. 20 milliamps is, we can just stop at 2. If that made any sense. 20 milliamps is about 20% of an amp. No, 2% of an amp. Ugh. Brain fried. I've already been doing a lot of this math, as you can already tell. So 6 volts. Okay, going to the power thing here. To calculate voltage, volts equals current, I equals current, times resistance, voltage. Okay, so with that being said, then resistance would equal voltage divided by current. And technically current would be equal to voltage divided by resistance. So, given the fact that we need to know how much our resistance needs to be, we need to do 6 divided by 0.02, which equals 300. And I just happen to have that right here on my phone. See? 300. So, 300 is our magic number. Now remember, circa, roughly 2 milliamps. So do we have to have 300 ohms? Or could we do 330 ohms, maybe 270 ohms? Now the problem with 300 is that it's not a common resistor. Just for fun, these are the common resistor numbers. Now, I do have a 220 and I have a 300, or a 330. I thought I would have a 2700, but I guess not. Or 270. So what we need is a orange, black, which is right here, orange, and then a black would be a 0, and that would make us 330. That's what these little rings are on here. You'll also notice that with the exception of white, black, gray, and brown, this is also the color spectrum for a rainbow. Also, I don't necessarily need to look at the actual ribbons because the measurements are on the labels. Oh, there's 330. Why is it? Oh, because it's time 10. Or no. Ugh. I'm not getting into this. So that means that if we find my 6-volt battery that I made in my little short video, hopefully I can still edit it into a short video. Keep getting these notifications. All right. Now you might be like, well, Dave, this is all great, grand and fun and everything, but which side do you, it doesn't matter. It's a resistor. Although I do believe that it should be on the positive side. So we've got that. Give me a second here. I actually have jumper wires with alligator clips, which, if you're in school, is the more likely thing that you're going to be playing around with. Make sure they don't touch. Possible sparks, possible fire, obviously low-grade fire, but, I mean, it's fire. The more you touch stuff. Now, I will say this. Sticking this in here and then bending it away is going to be a lot. Okay. Every time you add an element, wires, resistors, multiple batteries, whatever, it gives you the chance of having something else fail, and then you're sitting there scratching your head going, why doesn't my circuit work? Well, now you have to test even more things. So realistically, the less you have to connect, the better. Positive connects to the positive side. Whoop. And you always want to go for the most secure option possible. All right. And we have a working UV LED, very powerful, by the way, too, that is actually working and safe to use, because now we're down to, I believe, going to, because we went with 330, the amps, or the current coming out, is going to be 0.18. And that's because while we got to the number 300, we have to go calculate this back and say that the current is the voltage divided by the resistance. Did I seriously just do that? Oh. At 18 minutes in, I just showed my... God. All right, so 6 divided by 330 equals 0.018. So we're at 18 milliamps, which is it's roughly 20 milliamps. And that's why this whole thing works. And now I can go cure something, or I can set this up to potentially shine inside of a violin, so that I can, which was the original idea, by the way. The original idea of this was to shine into a violin to potentially de-smell this violin. But I'm pretty excited that it worked. It was just a little project that I wanted to work on. I've actually been, I'm just going to make sure that these leads don't touch. I've actually been looking at doing some electronics videos. So if you enjoyed this one, let me know. I've got a lot of stuff that I kind of want to put out in the future. Obviously, I need to go over a lot of stuff, like reading resistor bands. And we could have talked about voltage drop over the resistor and everything. But this is a part of my daily life. I actually use all of this stuff mostly for fixing things that my kids broke. So thank you for following along. I guess a lot of the things that you should have gotten out of here was researching how to identify parts and making sure that you know beforehand how to calculate for the requirements of this, because I mean, in all honesty, a UV LED is something that is a little bit harder to replace, especially one that is capable of curing. I know that there's a lot of UV things on the market that are not true UV. So, properly identifying stuff. We talked about batteries in series or power sources in series. And we talked about the power formulas for voltage, resistance, and current, and some common diagram things here. Short line, long line, short line, long line is a battery. And then this is not a typical diagram portion for an LED. This is just how I drew the LED, how it actually looks. I believe that in this diagram, usually it is this, with the triangle pointing this way. And then with an LED, I believe it's two arrows that point up at an angle, indicating that it shows light. In this case, because I believe that is the positive, that is the negative, I would have probably drawn it like this and whatnot. Which, I mean, as long as you get it, it's fine. I believe in diagrams it's fine, but because in a lot of cases, you're going to end up where you have a lot of different things in a diagram, and you can't have them all facing in the same direction in the book direction. So it's fine to mark it like this. I'm just saying usually you'll find it an LED icon like this. Should I talk about the fact that LED means light emitting diode? Or are we good? We're good? Okay.